sklearnmetricslogloss. Description: explain in detail. Inputs: why true, the true labels of the data. This is a 1D array of integers or strings, representing the true class labels of each data point. YPRED, the predicted probabilities of the data. This is a 2D array of floats, where each row represents a data point, and each column represents the probability of belonging to a particular class. The number of columns must match the number of classes in the dataset. Logloss: the log loss value for the given predictions and true labels. This is a single float value that represents the average negative log likelihood of the predicted probabilities. Steps: calculate the negative log likelihood of each predicted probability for each data point. Average the negative log likelihood values over all data points. Metrics: log loss is a metric that measures the performance of a classification model. It is a measure of the difference between the predicted probabilities and the actual true labels. Lower log loss values indicate better model performance. Visualization plots: a plot of the log loss value over time can be used to monitor the performance of a model during training. A plot of the log loss value for different values of a hyperparameter can be used to select the best value for that hyperparameter. APES: this parameter controls the numerical stability of the calculation. It is a small positive number that is added to the predicted probabilities to avoid taking the logarithm of 0. Normalize: this parameter determines whether the log loss is normalized by the number of data points. If set to true, the log loss is normalized by the number of data points, resulting in a value that is independent of the size of the dataset. If set to false, the log loss is not normalized. Log loss can be used to estimate the uncertainty of a model's predictions. A higher log loss value indicates higher uncertainty in the model's predictions. Challenge: 1 log loss can be sensitive to outliers. Sample use case that resulted in challenge 1 is single outlier data point with a very low predicted probability can have a significant impact on the log loss value. Fixes to challenge 1. One way to address this issue is to use a robust version of log loss, such as the Huber loss function. Challenge 2: log loss can be difficult to interpret for multi-class classification problems. Sample use case that resulted in challenge 2: it is not always clear how to interpret the log loss value for a multi-class classification problem with more than 2 classes. Fixes to challenge 2. One approach is to use a visualization tool to plot the log loss value for each class. This can help to understand the relative performance of the model for each class.